Once again, I welcome you, dear students, for the chemistry classes that we are teaching chemical kinetics in organic chemistry. In this one, we had completed different concepts. Today, the new concept, I switch on to that new concept of life reaction. Regarding the half-life reaction, half-life period in 10th standard, earlier classes. Half-life means, half-life of the element means the time taken to reduce is half of initial concentration. So here the half-life of reaction is also same. The time during which the concentration of the reactants is reduced to half of its initial concentration. Here we are reducing the initial concentration to its half of its level. So I repeat, the time during which the concentration of the reactants is reduced to half of initial concentration. So this is called half-life of reaction. As we learned in the order of reactions, zero order reaction, first order reaction, again we go for the half-life reaction also. This can be taught like this. The time takes for the completion of the reaction, that is, it is also depends upon the concentration, the basic concepts. Now I come to that one, half-life of zero order reaction. We already know that one, half-life of zero order reaction in the earlier classes. This is the basic concepts. We know that zero order reaction is equal to K into the concentration of A, that's an initial concentration, minus final concentration divided by T. This is the zero order reaction. Then here's an, for half-life, just we are changing the values. T is equal to T and half and A is equal to A naught by 2. This is the half of the initial concentration. So that we change into this one. Just we are changing T is equal to T and half. K is equal to initial concentration minus then A naught by 2. Here it should be A naught. Here it should be the A naught. A naught by 2. Then half of the initial concentration. Then it becomes T half is equal to, just rearranging these two values. Then we are writing 1 by K. The K comes to denominator part and A naught minus A base initial concentration 0, then minus A naught, that's in 0 concentration, divided by 2 half of itself. That is to be taken as, here by taking LCM of these two, if there is no number 1, then by taking the LCM we are getting the 2 and then K2K, that's will be there, and by simplifying last we get this one. Half-life of the zero order reaction is T half is equal to A naught, the concentration of A, the base 0, that is initial concentration, divided by 2K. So by this one you are maybe asked the sums and also the one definition for the half-life of first order zero order reaction. Similarly we get zero order reactions also. Again I come to that another one. How do we use this half-life of zero order reaction? Through the graph. Observe here, T and half is there, half-life period and the concentration. If you plot the graph, T half versus initial concentration, then we are getting a slope. That slope is equal to 1 by 2K. So this is the another graph of that one. So same type, we go for half-life of first order reaction. Half-life of first order reaction. Initially we know that one, T is equal to 2.303 divided by K into log of A by A minus X. In the last first order reaction, just we are changed that T and K value. There we had taken K and just interchange it because the time is important for you. Then rearrange the values of T and K. Then T is equal to 2.303 by K into log of A by A minus X. Again change that values. T is equal to T and half, that's half-life period, and X is the concentration, how that one, A by 2, half of the concentration of the initial concentration. Then this equation becomes like this. T becomes T and half and 2.303 as it is same K. then log of a by a minus x becomes a by 2. So we are changing the x value into a by 2. Then the equation becomes T of is equal to 2.303 k. Then by changing the denominators, by simplification we will get log 2. Here's a 2a and then 1a, 2a, 1a, 1a, a get cancelled, 2, that log 2 will come. Log 2 value is in log 2. Again the same value is at 2.303 by k, 2.303 by k into 3010. So T and of is equal to, the last answer is 0.693 divided by k. This is the last term of the last equation for the half-life of first order reaction. On this you are asked to do the derivation, or you get that to solve the sums on this basis by giving the different variables, by giving the k constant, and you have to find T of. So this is the another one. Then after we go for very important one, integrated rate equations. Just I take the gap. Once again I continue. Thank you.